All right, so yesterday we talked a little bit about, like, we covered some terms and definitions, and then we started to actually look at, this is one way of representing sets using a Venn diagram, okay? So we've got, in this case, only two sets. We've got set A, set B, and we started to talk about if we just want to refer to this green part, we use this notation, and in words it would be we want only what's in A but not in B. Right? If you're referring to this section, you have to be comfortable with the notation, and we mean B not A. If we want this section in orange, which means students that are in both classes, applied and biology, if you just want that, right? Both in A and B, we're referring to this notation. And then the last one, I don't know how to fit that in, but I'm going to give it my best shot here. If you wanted anything that's in these sets, okay, if you wanted, I know how I'm going to do this. I'm going to use this highlighter. If you wanted to talk about students that are in either of those, okay, that's this one that I'm going to just refer to here. We call that A union B. Okay, so I'm going to highlight that with that color, and I'm going to tell you how we refer to it using words. Okay, we would say elements that are in either set. Can you see that? Elements that are in either of the sets. So that's one way of referring to it. Okay. Another way is elements that are in at least one set. Yikes. Didn't plan on this taking up that much room. In either one. So union means it could be students that are only taking applied. It could be students that are taking both. It could be students that are only in biology, right? It could be any of these three sections, right? Any of those students, those are the ones we're referring to when it's or. And remember, we do not include outliers in here. We only care about the students that are somewhere in this area here, 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 or here. There are three areas, right, formed by those two circles. So we only care about that when it's union. When it's and, we only care about students that are in both classes at the same time. Okay? So I hope that maybe somebody's happy. It must, because it's Friday. Somebody's birthday. Is it somebody's birthday today? You can sing. Anyways, now we're talking about formulas, okay? So please don't freak out when you see this. I'm going to zoom out a little bit. I want to have the diagram and those three formulas. So it turns out that to find the number of elements that are in either A or B, right, this is the union, you could take your universal, you could consider the entire thing and subtract, what do we call this again? This notation, anybody? You see here? Those are the outliers, the union not. So whatever is not in the union is called the outliers. So if you need a reminder, okay, take the universal, subtract the outliers. That's how you find out the number of elements that are in either one of those. Okay? Second formula. You got to pay attention to this one. So this is one way to find the union. Then there's another way to find a union. What do? We add up whatever was in the green. So if you're highlighting the way I'm highlighting, I will say, make a reference to this green section here. You can add up whatever is in there. What did we use for the middle? We used orange, right? Orange for this part right here. You add that as well. And I used purple for that other section, which is only B. That one is right there. So another way to find the union is to just add up those three sections here. There won't always be a Venn diagram, but right now I can use it to help us out, right? So if you add up these three sections, you also get the union. That's another way of doing it. And last but not least, I hope you can see that another way of finding elements that are in either is to take A, follow me here, take all of A, this would be A, right? Plus, take all of B, this is B right here, minus the intersection, highlight that in orange. Why would we have to take away the intersection, guys? Because it's like surface area, you're doubling up, right? Because think about it. If you add all of A, look at where I'm circling here, and then you add up all of B, you're adding this area twice. Therefore, we must take away one of the intersections so that you're not doubling up. And hopefully that's going to become a bit more apparent. And I will add a little note here. And this is probably worth highlighting that A union B does not include outliers. You got to make sure you understand that. It refers to the elements that exist in at least one of the sets. Okay, so that's very important. And you might ask, why do you give us 3? Because we might use one or the other depending on the situation. Okay, that's just why we do that. And then the most common one that I use is down here. So if you need to like put a little cloud or highlight that, this version is the one I use most often. They're all useful to us. All right, now let's dive in, and we're going to use these ones in conjunction with other methods, perhaps. I will say this. Some of you might not use these formulas to solve. That's fine. If you can wrap your head around it, that is fine. So let's go to 13 here. And I use, when I talk about pi, it's a way to reason, right? It's basically using the formulas here. So we're talking about joint sets. W represents students walking to school. B represents student biking to school. Okay, driving, we don't have that in here, but I'm sure some of you are driving these days. So determine the union of W or B. Okay, I'm gonna write this out. In this particular context, number of students who either bike or walk. Another way of saying it would be number of students that are in either of these categories. Okay, they do one of these activities. I'm going to do that. I won't be doing that all the time. Number students, sorry, I forgot the S there. Number of students who use at least one method of transportation. Okay, that's another way. That's what that notation is referring to. Okay, so sometimes I will just flat out just use words. You should know, oh, he's talking about union. Or sometimes I just flat out give you the notation. You should also know what that means. Okay, so We know that, for example, N, W, or B. Let's do it the like the way that most of you would probably identify with. These, how many students are just walking? I'm 3, right? 3 plus, how many students are doing both? They sometimes walk and they sometimes bike. 3, right? How many students are only biking? 2. That would be a total of 8. I'm keeping the numbers nice and small, right? 8 students. We're talking, if there's a context, then make sure you add the units to it. 8 students. Which formula did we use in this case? How would we refer to these 3 right here? What notation would we use? Mr. Dixon, it's way too early in the morning. Can you just give me the answer? Sure. Right? That is what I did first. And then I added, how do I refer to these 3 using notation? W and B, right? Plus, how do I refer to the 2 here that are only biking? I just want biking. I don't want students that walk, right? In this case. And that's the formula that I used here. I'm going to box this in. This is one way of doing it. Please don't write this off. Like, don't say like, oh, this is weird. This is weird. I just can't do this. Don't do it yet. Give me a couple of days and I'll win you over, okay? What if I asked you to do this again using a different method? We want students that are in either one of those. Can I figure out the universal here real quick? How many students do I have in total? Like, what number should I have at the top here? I have 6, right? Sorry, 8. I have 8 here, plus I have another 2 outliers. So how many students do I have in total? 10. I can do that by observation. Could I go 10 minus 2? Could I say that the number of students that are in either sets is the total minus the 2 students that are in neither one of those? I would still get 8 students, right? I used up way too much space with these statements up here, guys. Sorry. I made a mistake. So what I've used here is I've used the universal, and I took away, how do you refer to the outliers again in this case? W or B, and I'm going to put a little tick there. These are the outliers. Okay, that is another method. And last but not least, we're going to do the third one here, the one I will introduce. This one is probably a little different. Let's go up here real quick to the diagram. How many students are walking in this scenario? How many? Walking. 3 are only walking. But look at the circle, walking. It includes all of this, right? So it's 3 and 3. So there are actually 6 students in this case. If I asked you, do you walk to school? You would say yes. 6 students walk to school. How many students bike? 5. Okay. Put a 5 there. So it would be incorrect to say the number of students that walk or bike is 6 plus 5, right? What does that add up to? 11. That's wrong. We know it's just 8, right? So that's where that third one comes in. So watch this. is going to be 6 plus 5 minus 3, because I double counted that. 11 minus 3 is 8 students. Why did you do that? That's weird. I used this formula right here. This is the principle of inclusion and exclusion highlighted. So it's n of W plus n of B, so number of students that are biking, minus n of, what's that 3? How do I refer to this section again? W and B. Okay, so this is the third formula. So there are 3 ways of doing Mr. Dixon. This was way too confusing. Why did you do that? I wanted you to see it's possible to figure out how many are in either one of those groups using the 3 methods, but you get to pick whichever one you want to use. Okay? All right. We're going to skip this part. We're going to skip this part. I want you to right now fill this in right here, this part. Using our diagram, what would be the universal? Like how many students are in the universal? How many students are in this? How many students are in this set? So I want you to actually fill that in with numbers. Looking at the diagram, I want you to kind of just see where it is. Maybe you have to go back in your notes a little bit. Figure out what would be the area I'm talking about in the Venn diagram, and then put a number down. Where is this? Put a number down. What is that? Maybe you have to ask your neighbor or go back in the notes. Put a number down, okay? So from C to E, please do that right now. We still got to chug along. Way to go, guys. Some of you had very good questions, so make sure you follow along because I will add some things that might help you. N of U, in this case, we know it is 10. W only, let me have the diagram on there, otherwise. What's W only? This is only W, okay? There are 3 elements. Notice that N in front of it, it asks you for the number of elements that are in there. That's 3, that's correct. B only would be 2. Okay, so only these 2 is B only. If it's not W, how do I do not W? Visually, you want to cover up W, and what are you left with? There are 4 elements, so it's just get rid of W, and whatever remains is what you're looking for. So we're talking 4 elements there. I would like you to, okay, this is a common one. What do we call not? What is not W is the complement, correct? Is the complement. I want you to think of N not. I want you to take the universal and take away whatever is in W. Remember that one? I hope you do. If not, today is another day. What's my universal? 10, right? How many are in W right now? Like walking. We did that up on the diagram. How many are in there? 6. And so that's 4. And that's how we got our 4. This is not using a Venn diagram. This is just using the formulas, right? What about this one? State this. What I'm asking for is actually, there's no N in front of it, so you actually want to state the elements that are found in this region. Which, if you look up, it's these 3 students. They do both. They walk and they bike. So ideally, you want them arranged. So I would start with Anna, Jenna, and Xenia. Squiggly brackets. The province is picky on the squiggly brackets, so make something squiggly and I give you the marks, okay? Doesn't have to look pretty. But there it's asking for, hey, give me the actual elements that are in this set, right, in this region. Use set notation to write set W. Who is in W? We'll just do this. W is all of W, guys. So the whole circle. I'm going to go Anna. Who's next? Biff. I try to make it somewhat easy to have. So Chip. Damien. Who's next? Jenna. I feel like I'm forgetting one. 1, 2, 3, 4, 5. There's supposed to be 6, so we're good. We have 6 elements in W. These are the students that walk. Okay? Question. Is B, what do we call that symbol? Subset, right? Is B a subset of W? I could have told you right off the bat. When I just look at that diagram, I can tell you no. Because you don't have the nesting, right? You don't have that nested situation. But if you didn't know that, you would just have to look at the elements in each of those sets and say, hey, wait a minute, not all students that bike are also walking, okay? So you would say B is not a subset of W since not all elements, not all elements of B are also in W. So that's like the ultimate test for subsets. I need to see that every single element of the one that I'm claiming as a subset of the other is found in that other one. That's the only way things are subsets of each other. Okay? Phew, right? I want to do one more thing before I do a word problem. I want to go back to our diagram and just real quick, I'm going to go up to the top here. This one, let's just quickly label these regions. If I only wanted students that were walking, I would use this notation. Okay? If I only wanted to refer to students that bike, I would use this notation. It's a bit blurry, right? Or is it just my eyes? Maybe that I'm getting older. If you want that region in between, like just this one, we would go W and B. So the and is they have to be in both. So it's kind of like the intersection. Okay, so get used to this notation. How would I refer to the outliers here? What's the notation in this particular case? I would call that W or B not. I know it's very weird. It's very weird how we talk about, right? Like, why can't you just say it differently? But that's how we refer to it. It's like, hey, think of the union, which is all the ones that are in the set, but we don't want those. Okay, well, then it's whatever's left over. Okay? That's how I think about it. Okay. Hopefully you're starting to wrap your head around it. I'm going to skip with 14. I'm going to skip 14 for now. We're going to go straight into word problems. This is on page 15. And I know the province will not always prompt you to make a Venn diagram, but I would strongly recommend just make your Venn diagram, guys, and fill in the numbers where they belong. The biggest problem is students don't put the numbers where they belong in the Venn diagram because they don't read carefully. But if you follow my program, you should be fine. Okay. So I'm asking you to do the Venn diagram and fill in the info provided. So let's read first and foremost. During the pandemic, a school sent out surveys to 50 homes asking what types of devices were available to students. We have 30 students that were able to access a tablet. So when there's a letter, use it, please. If I don't give you a letter, you make your own. But we have 30 students that are using tablets. We've got 25 students that are using a computer. We've got 5 students who had access to neither. let me ask you, what do you think the 5 students, what would we call them in this unit? Outliers. We would call them outliers, okay? So outliers. And how would we refer to them in a fancy way? Using these letters. T or C, not. Students that are neither one of those sets that we were just introduced to, okay? So when you can see that, sure, why not? How would you write this in set notation? N of T, the number of students that are using tablets, would be 30, correct? And the number of students that have a computer is 25. Notice, none of these are saying 30 students were able to access tablets only. It doesn't say that. It just says tablets. It could be that these 30 also have a computer, right? Like it could be. We don't know that. So we'll figure that out. So let's draw our Venn diagram here. I'm going to call the first one T. Is it possible that there's an overlap? It is possible. So we're going to go ahead and do this. T, and this is C. And we know that there are 30 that belong to this circle, and there are 25 students that belong to this circle. Don't forget your box. Do we know the universal? Because not always will you know, but do we know the universal in this case? 50, right? 50 homes. 50 students were asked. What if a home has twins, Mr. Dirksen? Doesn't that mess everything up? Don't do that. Don't overthink it. So this is NU is 50. So we're sending it out to 50 students. So that's our universal. That's where we're drawing from. Okay? So we've got that taken care of. And now you have a bit of a problem. Okay? First of all, I will just make a note here. If I were to add up, if you add up the two sets that are there, you get 30 plus 25. What does that add up to? 55. Isn't that a problem? How many do we have in total? 50. So you know that there's a problem. That means that there's an overlap. Some students have both. Some students answered yes to both. So since 55 is greater than the universal, comma, we have joint sets. You know that. You know that they, if this is true, that some have answered yes to both. Otherwise, right, 30 and 25 is more than 50, like something is wrong here. Okay, so you know that there's an overlap. So what we're going to do is we're going to label these sections. This one is T and C. Okay. And I will tell you the one that my preferred method of solving these ones. You can tell that 5, in this case, 5 answered yes to both. Okay, that's why we're over. I'm going to tell you this one. Oh, I'm missing one. What number is still missing in this diagram right now? The 5 outliers. Put them somewhere out here. I usually put them in the right corner. I don't know. That's just how I do it. So, I will tell you this. This is the one I like to use most. The principle of inclusion and exclusion, pi, tells me that if I want to know how many are in either one of these sets, I just have to take the set T. I have to take the number of students that are in C. And I have to make sure I subtract the overlap. Okay, I don't want to rush this, okay? Put your finger on this and go back to those three formulas. I want you to have it on your study sheet, by the way. Let's go back to those three formulas I introduced you to. I'm using, which one am I using right now? I'm using this last one here. Why, Mr. Dirksen? Why are you using that one? Because I'm able to figure this out. I'm able to figure that one out. This one, I just don't know the intersection. Okay? So that's why I'm using this one. Why not that one, Mr. Dirksen? Because I don't know how many students are only having a tablet or how many students are only have a computer. I don't know that. There's too many unknowns. That's why I don't use this one. And this one right here will also not help us a great deal. It will not help us a great deal because it will just tell us how many are in both sets combined. So I tend to use this one almost exclusively. Okay. So watch this. A number of T or C. How many students are in either one of those? Watch this. You go 50 minus 5. Okay? We always take our universal, we subtract any outliers if there are any, and then we fill in the rest. There are 30 in set T, there are 25 in set C, and this one is unknown to me. Down the road, I'm just going to call this X, like when I don't know a number, I'll just call it X and I'll solve for X. Okay? And now it's just 50 minus 5 is 45, 30 plus 25 is 55 minus, these are the students that are in both, that have a tablet and a computer. What do I do now? I subtract 55 from both sides. 45 minus 55 is negative 10. Okay? And on this side, you're left with negative T and C. What do I do now? I don't know what you've teachers done before. Some teachers just change the signs for both sides, but I divide both sides by negative 1. And so we've got 10 is equal to T and C. Why did you do that? It never asked you to do it. You need that to fill in your Venn diagram. And now we're ready to do the rest. This is key. I'm going to highlight this one. This is effectively giving us the number that goes into that region right there. So once you find the middle, it's a cascading effect. It's a ripple effect. Okay? You've got the 10. How many students should be in here then? In this region right here? 20. Right? There should be 20 in this region because you go 30 in total minus 10. So I'm going to go 30 minus 10. So there should be 20 in that region. And over on this region, 25 minus 10. So we're looking at 15 students that are only having access to a computer. And now the ultimate test, the ultimate check, if you did this right. What should all of these regions add up to? 50. So let's try it. 20 and 10, that's 30, right? That's 45. That's 50. You know you did this right. Okay. So there's your universal 50. So Venn diagram like this, I couldn't do it right off the bat. I had to resort to this, the principle of inclusion and exclusion, to figure out the middle. The most common mistake is students forget to subtract the negative 5, and then it doesn't jive. Like it just doesn't work. Okay. So the A is done. Let's do B. How many students I actually did B right now. And sometimes, how many students were able to access both a tablet and a computer? It's this one right here. So I'll do B, just answer 10 students. I will see the work and I'll just go off of your work for that one. So if you want to box this in, that's fine. C, how many students only had a tablet available? Please use notation to review this. Tablet, but not a computer. What would that be? 20? All right. 20 students. You got to add units here because there's a context. D, how many students only had a computer? So basically computer, but not a tablet. We are looking at the 15 there. How many students? E, well, how would you answer that one? How many students had at least a computer or a table? I hope you had a table available. A tablet available. Sorry, you can't even see the question. Sorry. There. Tablet available. So this one is asking for this. Tablet or computer. When it says at least, you're asking for the union. Okay? So let me just zoom back down. So that's where you choose what you want to do. How do you find the union? You go universal minus outliers. That's one way of doing it. Or you go up here to your diagram and just like 20 and 10, that's 30, plus 15 is 45. But it is 45 students. At least one. So it's either just tablet or both or a computer. And I gave you the neither already, but it could have asked how many students had access to neither or did not have access to either of both, did not have access to either of both. That would have been your outliers. Sometimes the outliers are something you need to find. Okay? So let me remind you, you will probably be given enough information, not probably, you will be given enough information to fill in that one number that's going to, usually if the center is missing, then you fill that in and then you just fill out the rest as it goes, okay? All right, I want you to, let's go to 16. For now, I just want you to read it. Next to every bullet like this, every bullet, I want you to use the proper notation. Like what would be the proper notation to refer to that statement? So basically translate that statement into notation. And I want you to draw a Venn diagram and put the numbers where they belong. Don't solve anything yet. Just rewrite this using notation so we practice that. And then make your Venn diagram somewhere down here where you put the numbers in the proper location. That is very important before we continue. So go give that a try. And if you feel confident, sure, go solve it. I'm not going to stop you. Let's see how you did here. 17 students like summer only. I'm going to, because there are no letters, I'm just going to put an S next to that one. This particular, because of the only, you would want to say summer only, right? Summer, but not winter. I guess winter is the other one in play here. That would be 17. 11 students liked winter and summer. How would you refer to that one? Like this. And is the, think of the N for and, okay? And that would be 11. 5 did not like either season. That's when you want to or. Mr. Dirksen, would it matter if I went W or S? It would not matter, okay? You just have to make sure you do one of these or a little tick. So that would be 5. These are my outliers. And I will just make sure everybody knows S stands for summer and W stands for winter. So, right, making sure I define my variables. So there we go. Determine the number of students like winter only. Hold your horses. You know this is a Venn diagram situation. The 35 would be my NU, right? That's the universal. So let's see here. Let's do a bit of a check. Do we know that there's an overlap? In this case, yes, for sure, because it does say the and, right? So there's not even a doubt about that. And so now I'm curious where you put the numbers. I'm really curious about this one. I know that my universal is 35. So notice that we don't list the elements in them. We just look at the number of. And what do we know? The 17, where should it have gone? It should have gone in here, not out here. Okay? The 11. Go ahead. The 11, where does that one go? It's and, so that one goes there. The outliers, I know where that goes. Goes there. Okay. Let's fill in more. We actually know more already. 17 and 11, that would be 28, right? So that number should be 28. So is there a way to find this area here without using any of those annoying formulas? Absolutely. So you don't have to. So this is what they're asking us. This is what? W, not S, right? That's this region right here. So the number of students that only like winter should be 0, right? But anyways, we're going to go 35 minus 17 minus 11 minus the 5. And what are we left with? I don't even know the answer to this one. 35 minus 28 minus 5. It's Friday. I don't want to do math. 2 students. So the 2, I'm going to use a red pen for whatever I'm filling in afterwards. This is 2. And what's W? How many students like winter? 11 and 2. This is 13. So please don't be saying 2 out here. Okay? It's this whole. So what does that mean? Because there are some students that also like summer, right? But if you just wanted to know how many like winter, you would focus on that circle right there. So the answer, this is actually answering A right here. I'm just going to put A. I used my Venn diagram to aid me in finding this. Could you have used my scary formulas? Yes. Watch how I would do it if using pi. I'm going to use this one. How does this go again? The popular one, n of s plus n of w minus n of s and w. It's almost like SMW. Anyways, do we know this here? Remember, it's 35 minus 5. So I always write it like that so you don't forget. Do we know NS? We figured it out. We had to do a little bit of digging, but when we filled this in, we figured out that's 28. Do we know N of W originally? Please say no, because this was empty, right? There's no way of finding W. So you just say, I don't know what that is. Minus, don't forget to minus the N. Do we know the intersection? Was that given to us? Yes. And now it's just solve for x, right? So this is 30 is equal to 28. I'm going to go minus 11 plus NW. Oops. Sorry, Vince, did something fly your way there? No? You're fine. 30, and this would be what, 17? Plus n of w. And then we subtract 17 from both sides. And what are we left with on this side? Oh, where's the 13? Does that make sense that we get 13? Yes. But that wouldn't have answered the question yet, would it? We would have had to go 13 minus 11 to give us the section that we actually want. Scratch, 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 right? So you do whatever you feel works for you. At the end of the day, if you add up all these sections, it has to add up to 35. That's bottom line what you need to do. If you come up with a negative, go back. You're missing something. You can't have negatives in here, okay? All right, so A is taken care of. I'm going to box in this whole thing here, and I will make a note that this is an alternate solution. Alternate method, right? So just so you know that you could have done it that way. Okay, B, what's B asking? Determine the number of students that like either winter or summer. Emphasis on the or. We're thinking union, right? Oops, you can see that up here, but or means union. So they're asking for this. Winter or summer. We already know that that's 35 minus 5. It is 30, right? It's whatever is in these circles. If you add that all up, you get 30, or if you go universal minus outliers, you get 30. It's up to you. 30 students. C, draw Venn diagram. Done. Okay, it's already done. You're like, what? Sometimes they ask you to do the Venn diagram first and then a bunch of questions. And the answer is, do the work first if you need to, come back to the Venn diagram, fill it in even more. And by filling in, a complete Venn diagram should have numbers in every single region, including these numbers there. And don't forget about your universal. All right? So, I have questions for you. And hopefully you have answers. We're going to go all the way to 19. I'm going to say for now, pages 18 to 19, and then I want you to also do 17 after. 17 is kind of a review of what we've been doing before this, where you just create your sets, you talk about subsets, anything like that. So pages 18 to 19 are word problems. There should be a Venn diagram. Even if it doesn't ask you, you should have a Venn diagram. That's like part of your work. Okay? And then 17 as a review. Do yourselves a huge favor and do this for homework. Because even if you're not sure what's happening, if you come back on Monday, you're going to be able to actually pay attention and focus on what you're still missing. Okay? You have the rest of the class to